Okay guys, so I hope that you have been enjoying all the upgrades that I have been showing, like from the wasteboard to the spindle upgrade. But I hope that you haven't done any of those, because today if you are willing to spend about like $50 more, I will show you a major upgrade or rebuild just will improve your machine tremendously. And you can see that I have this spindle on here now, but you can do this upgrade or rebuild just using your old spindle. First of all, it will improve the precision on this machine. What I meant by precision, just if you try to pull this setup this way, or pull this platform back and forth here, you will feel that it's kind of move a little bit. It have a gap about probably less than 1 millimeter, but it's quite big. That's probably not a big problem when you mill something soft like plywood or plastic, but when you mill something hard like aluminum or really hard wood, it might impact your mill because the stress when the spindle move this way or that way, this way, it will be different, and also back and forth is also different, so it might create imprecision in your part. This upgrade will remove that gap. And this upgrade will also improve the working range in the Z-axis, because I just going to take a chance to rebuild this Z-axis and make the working range as increase from 45 to 85 millimeter. And of course I will also include the spindle upgrade and the wasteboard in the redesign of this machine. So let me just show you the new design on the computer. Okay guys, so let's take a quick look at the new design just I made for this 3018 CNC. As you can see, just it look a bit taller. This because you will have to change this toolbar from 220 millimeter length to 300 millimeter. The reason for this is just to take full advantage of the new working range in the Z-axis. The gap here between this edge and this wasteboard is about 80 millimeter, so you still have about 5 millimeter to plunge into this wasteboard, and that's why the wasteboards are there for. Okay, so the hardest parts of this build are to make the angled aluminum pieces. Just I will have to make some drill guide for them. And the angled aluminum pieces, first of all, to mount the anti-backlash nuts, just will eliminate the gaps that I showed you earlier. And I also use some of the angled aluminum pieces to make a motor mount for the Z-axis. And here for the Z-axis setup, I just bought the whole set here. Just you're going to use some 8mm rail and some of the SC8UU linear bearing block. For the X and Y axis, you will have to buy some of the SC10UU linear bearing. Here on the X axis, instead of using 4 separate linear bearing block, I just going to use 2, and in each of the aluminum block here, I just going to install 2 linear bearing and lock them down by drilling some hole here and make the thread. Then use the set screw to lock them down, so to prevent them from moving in and out, and also remove the loose movement of the bearing inside the aluminum block. And on the y-axis, I'm just going to use 4 separate linear bearing block. This is just to make it a bit more stable, and you don't really need to drill those holes and thread them. But for me, I want to just really remove the loose movement of those linear bearing inside those blocks. So I'm just going to drill them, thread them, and also lock them down with the set screw. So in my first design, I want to make the plate out of aluminum about 5mm thick. But I went to the store today and they are out of stock, so I just going to have to make them out of plywood about 12mm thick, and though plywood are really easy to cut, so I will only show you the parts where I make some holes on the angled aluminum. The rest you just mill them with your 3018 CNC very easily. And for those who want to make this build, I'm just going to save all the pieces, just need to be milled in step format and put them in one folder. And for all the parts that you need to buy, don't worry about them. I'm just going to put the list and also the links in the description of the video. Okay guys, so before start milling all the parts, just make sure that you check if your X and Y axis are really like orthogonal to each other, because I just checked mine and it wasn't. And it took me a few attempts to use the 3-hole drill calibration trick to like adjust the X and Y axis. If you want to know more about this trick, just check my other videos. It's the video about 3-axis CNC calibration trick for high precision cutting. And if you really want to know how to do it on this CNC machine, I can make another video and show you step by step. But for now, I have these 2 axes calibrated, so I'm just going to start milling all the parts. And one more thing, just in the design that I share, there's 2 folders, just have the step files. Just one is just I save all the pieces like part by part, like separately. And another folder, just I regroup like all the parts that have the same thickness together, so you can mill like all of them at once. So I recommend you to use that folder. Okay, so now let me just cut all the pieces and show you how I make the hole on the angled aluminum. Okay guys, so now I have all the drill guides just milled out here. You should have 5 pairs. 2 pairs are for the motor mounts and 3 pairs are for the nut housing pieces. And that's why I cut here 5 pieces of angled aluminum. They are like 3 mm thick on the side, and this dimension is about 1.25 inches, so it's about 32 millimeter. And the width that I cut here is also like 32 millimeter. So next step is just I take the pieces here. I just align the edge here and push it all the way in, and I'm going to glue them all around. And then I take the other piece, I just slide in the slot, align the edge, and push it all the way in also, and glue this part. So that way it's not going to move, and I'm just going to use the corresponding drill bit and drill those through. So those 4 holes will be 4 millimeter. Those 4 holes will be like 2 millimeter, and the center hole will be like 10 millimeter. So roughly like that. You just look at the design on the computer and see which drill bit you will need. So let me just glue them on here. Okay, so after gluing, the pieces will look like this, and this is not going to move anywhere when you drill. And the reason that I use the thermal glue or glue gun, because it will be quick cure, and it also very easy to peel off later once you are done with the drilling. Okay guys, so now all the pieces are glued together. Next step, I'm just going to go to the drill press and pre-drill all the holes here. But before doing that, I'm actually going to take the chance to dismount all the bearing, make the mark to drill the holes. because I just going to drill all the holes, so I just take the chance to drill the holes on the back of the aluminum block too. So to dismount this, you just take the snap ring plier, just take the snap ring out, and well, normally you can just push the bearing out very easily because they are quite loose, and that's why there's an imprecision in here. Okay, so dismounting the bearing was easy. The next step just to mark some place where you're going to drill the holes. On the x-axis, I just going to drill 4 holes and 2 of them on each side. So I will have 2 set screws to set one bearing down. And on the y-axis, I said only need to drill like 2 holes, one on each side to lock them down. And on the z-axis is smaller bearing. I'm going to drill also just 2 holes on each to set the bearing inside down. Yeah, just do something roughly like this. Just a mark here, so I can just drill roughly there. Okay, so you can see I have 2 for the x-axis and 4 for the y-axis, and for the z-axis I need 4 of this, but I already have like 2 on the setup that I have right now, so I just going to reuse them, and I have these 2 new ones. So I could just going to drill all the holes here with 2mm drill bit, and then I'm going to thread them with M3 tab. Okay, so as you can see that I have some inconsistency in the bearing. This one really tight, just I cannot push it out, and those just slide right off. So yeah, they are quite cheap, so you have to like do your best to improve the precision of those bearings. Okay, so now all the bearings are dismounted. Next step is to the drill press. Okay, so as you can see that drilling and tapping this type of aluminum block was really easy. So I'm just going to do it on all of them. Okay guys, so now to the hardest part of this build is to make all the holes on this angled aluminum piece for the nut housing. The other 2 pieces for the motor mount are really easy. So I'm just going to show you how to make them on this one. So I'm just going to use here the 2.5mm drill bit. So I'm just going to make the kind of the mark, so like pre-drill or spotting drill first, and then I'm going to take off all the piece of plastic and then drill all the way through. Okay, so now there's one hole in here. I cannot really drill because it's blocked by this piece, so I'm just going to cut this piece out, take it out, and drill that hole. So as I told you before, this thermal glue is really easy to work with. In this application, you can just like peel it off. Okay, so now all the holes are pre-drilled. I'm just going to cut this piece out also. Okay, as you can see, I have all the holes just pre-drilled here. Just have the mark on it. So now I'm just going to take the corresponding drill bit and drill all the way through. For these 4 holes here on the nut side, I'm just going to drill with a 2.5mm drill bit and then thread them with M3 tap. And for these holes, I just drill them with the 3mm drill bit and tap them with the M4 tap. And the hole in the middle here, I'm just going to use the 10mm drill bit. Okay guys, so now to drill the hole in the center here to 10mm, I'm just going to do it progressively, like from there, like probably 4, 6, 8 and 10. Because last time when I tried the 10mm drill bit, there's a lot of vibration and it's really hard to hold on to this piece. So I just going to just do it slowly. So now I have all the holes just drilled and threads. So actually the hardest part wasn't that hard after all. Now I have all the pieces just mute, drill, cut, thread, whatever you need to do. Next step I just have to glue those pieces together. So I just use some wood glue here. So just put it here, just a little bit, don't need too much. Press it here. And I might need to clean up the extra glue inside. Okay, that's it for these pieces. So the next step I will show you how to put together the whole new build of the 3018 CNC. Okay guys, so the next step is to dismount the Z-axis block to get the stepper motor. And for me, I also need to get the 2 bearing block just I installed on here. And I also need to dismount the whole X-axis from this part up. The Y-axis, you don't need to touch it right now. If you already like install it right, like the rectangle base frame here, you can keep it the same. And the Y-axis, you can install it separately later. So let me just start with this block. Okay, so for the X-axis, you're going to keep everything except these 2 bars. You're going to replace with the new 300mm length bar. And for the Z-axis, I'm just going to keep these 2 bearing block and the stepper motor. This piece, you can throw it away or just keep it for later. I don't know, maybe you will want it for something. Okay, you want to keep this last screw on the x-axis too. From this block, we need the bearings here to be installed on the aluminum block that I drilled and thread earlier. Okay, so that was really easy. So probably that's why you see that my bearing just get loose sometimes. Though I just slide right off. Okay, so from this piece, just were supporting the end of the last screw here. I just going to take out the bearing and install on this piece that I glued earlier. Okay, from this block, you only need to replace these two boards. So I just going to dismount everything and keep most of the pieces. Okay, so now I have the pieces a bit everywhere, but let's just put things together. Okay, so we will start by put together the linear bearing for the x-axis. So you will slide two of those in one of the aluminum block like this with the 4 holes at the back. So from this edge to this edge is 11 millimeter on each side, so it will be like symmetrical, and then you just use the set screw to like lock them down so they don't move in and out. And here I use the M3 set screw because I have a lot of them. If you have other type of set screw, feel free to like drill and thread the holes here at the side that you have. Okay, so this way you should have the same range on the x-axis as you have before. They slide in really nicely, no problem, and I don't really feel much play here. Okay, so now I'm just going to put together the z-axis. For this, I'm just going to do it on the table because sitting down here just makes my legs really tired. Okay guys, so now moving on to the z-axis block. First of all, just start by install the coupler on the stepper motor, because later on, once you install on this, you won't have any more space to tighten the set screw. And then you just tighten the M3 bolt here to lock down the stepper motor to the plate. Okay, so next step, just take some of the M6, about 20 millimeter length, just slide in the slot here, like this. And well, you just slide these two pieces of angled aluminum here. Just make sure that the side of the angled aluminum just kind of almost line up to this edge. Okay, so now you can put it aside and use it later. Okay, next step, just move on to this plate. As you can see here, you have this side have 3 small holes and 1 big hole here. So here in the slot, just slide in the M6 nuts in here, and then just take one of the spacer, line it up like this, and then put one of the bearing block on this like this, and then use the M4 nuts to lock it down. Okay, so I ran into a bit of problem. It just I don't have the M4 bolt about 25 millimeter length. I only have 20 millimeter length, so it doesn't go through. So what I'm going to do is just I'm going to take a drill bit and drill it down a bit, so I can just have the bolt just go through long enough to bite on the bearing. Okay, so I just make some slot here with a big drill bit, so I think it will work now. Okay, so right now I just let them a bit loose, just enough to like hold the nut in place. Later on I will like slide the rail through and tighten them later. So let me just install all the other bearings. Okay, so we just leave them for now. So the next step is just take the Z-axis back block, it's the big plate here, and then just use this spacer, just lay it on like this, and then put the two bearing of the X-axis on this, and then bolt them down with the M5 bolt. You can use something like probably 35mm length M5 bolt would be perfect. Next step, I'm just going to install this piece of the nut housing on the X-axis and also the nut on here, because I'm going to reuse the lead screw on the X-axis, so you would have to buy like the 4mm lead nuts. Okay, so now I'm just going to install this on this piece like this, and just use some of the M4, like 30mm length will be fine. Okay, so now to the front of this Z-axis block, I have here the set of two rail and one lead screw. They are 200mm length, and this lead screw I prefer to have 2mm lead, because that will reduce the stretch on the Z-axis block, because it's quite heavy. Just remember to buy the corresponding nuts for it. Now just take one of the angle aluminum piece nut housing and install this nut on it. And this piece will be installed on this, like this way. So just use some of the M4 bolt. This one can be short, like 20mm will be good. Okay, so the next step, I'm just going to install the stepper motor here, and make sure that you have this like place to plug the wire here, here, or here, not at the bottom. Okay, so now the z-axis is done. Let's just put together the x-axis. Okay, so I got some changes compared to the design that I showed you. Just here I have a 2040 aluminum bar instead of 2020 because I have some already in stock and I just cut them to the length that I need. Okay, so if you have the 2020 bar, the place that you need to install is about 6 millimeter from this edge to this edge. So that way the spindle will be like right at the middle of the machine. But here, since I don't have the 2020, I'm going to install it like this. So I just like line up the slot here and make half of this bar like stuck at the back. So let me just install this quickly. Okay, this seems to be quite sturdy, but just to make sure, just going to add on one bracket on each side like this, so it will be really sturdy, and I will share this bracket also in the design that I share. Okay, so now I have these two bar installed. Next step is just install the back as before. Okay, so now I have the Z-axis block installed on the X-axis. Next step, I just going to install the spindle clamp. So supposedly I need about 65mm M6 bolt, but I only have like 80, so I just put some of the M8 nuts in here as spacer to lift them up like this. So I don't have it too long to poke into this linear bearing block. Okay guys, so now I have the Z and the X-axis finished. Let's see how they move. Okay, so I forgot that I changed the type of this last screw, so I have to change the parameter to 1600 steps per millimeter in the software. Well, as you can see that everything moves really smoothly at the maximum speed. And also one more thing, just if I try to pull it this way or that way, I cannot really feel the gap, or this up and down, I don't feel it, so that's a good thing. Okay, so for the people just who doesn't really care about the gap, you only want to increase the range in the Z-axis and also the spindle upgrade, you can just stop here and the machine should work as normal. But for the people who want the wasteboard and also remove the gap on the Y-axis, let's continue to put all the Y-axis together. This part should be easy. Okay guys, so now the bottom part is installed on here. Let's see how it moved first before I install the top part on it. Okay, so as you can see that it can move back and forth like really smoothly as it's supposed to. So next step I just got to install the top part and then the machine will be ready. Now the machine is ready. Let's just see one more time how all the axes moved. Okay, so on the Z-axis you can see that the tip of the spindle here go really close to the wasteboard, so that's why I would have more than enough thickness to like just plunge in. Okay guys, so as you can see that the machine moves really smoothly on all axes, so I'm really happy about it right now. And one thing that you can see that I don't have any gap anymore in all axes, so this should be a lot more precise compared to the original setup of the 3018 CNC. By now you're probably going to say just stop showing us all the upgrades, we want to see how it works. So next step I just going to show you one example of aluminum milling on this machine. I hope that you still remember this guy just I made with my original 3018 CNC. So today I just want to try to make a beer opener on this side. The thing is, just last time when I ran this guy, the machine was really shaky and it's kind of at its limit. Today with the new spindle, that is kind of the only thing that is better for this application. I just going to try to use the same parameter. If it cut really smooth, I can increase the plunge rate, the feed rate later. So here the setup to cut aluminum. This time I only have the air come in here and blast through this hose to the bit. So it kind of just blast the chip away. I'm not going to use water this time because it's kind of messy. So hopefully it's cut still smoothly. Okay guys, so after 3 hours and a half I got here a beer opener. It's fully milled and the side here is kind of smooth, it's not really rough, and I don't have any chip just stuck on the bit here, so the air to blow away the chip actually work. And for the milling of the aluminum here, I just going to say that it's still like possible. It's not really smooth yet. It's not like hot knife through butter because sometimes I still feel like it has some kind of vibration. This I think mostly because of the rails or all axes are not fully supported. So if you intend to do a lot of aluminum, I still recommend you to buy another type of CNC just have fully supported rail. Just to summarize about this upgrade, it has many advantages. First of all, you can cut all the pieces very easily with your original 3018 CNC. Second of all, is remove all the gaps on all axes and it improve the precision on your machine. It's already include the wasteboard in the design and also the spindle upgrade. It increased the range in the Z-axis, and also I didn't tell you before, just it increased the range in the Y-axis from 180 millimeter to 195 millimeter. I hope that this upgrade is helpful and hopefully it will make it your machine.